hypothesis testing of a population proportion using the critical regions method. Example 2. Our null hypothesis, our alternative hypothesis, and this time we're testing for greater than. So we get this binomial distribution because we're taking a random sample of size 9, and this p-value comes from here. This is a one-tailed test. We're using a 10% level of significance. So we start with our number line again, so x can take any value from 0 up to 9. And because h1 is greater than, the arrow is pointing to the right, our critical region will be on the right hand side this time, the upper tail. So we need to work out the value of our critical value here. So we know the probability of the critical region will be at most 10%. That was the significance level. The problem is we cannot use tables or even the calculator because we have x greater than or equal to. We need to work with cumulative probabilities. We want x less than or equal to use probability tables or the calculator. So we have to work on this side, on the left hand side. So this is the acceptance region. The value here will be 1 less than the critical value. I'll just represent that with a question mark at the moment. I need to work out this unknown value. So this region represents px less than or equal to my unknown value here. And from the tables I'm looking for the first probability that is just above 90%. This is at most 10%, so the probability of this side will be something just below 10%. So this has to be something just above 90% for them to add up to 100%, or the probabilities to add up to 1. So going to the tables and looking at this side for less than or equal to, which we can use with the probability tables. So the first one above 90, it's this here. So that's the probability that we're interested in, and that corresponds to the first one above 90%. And 6 is the unknown value here. So that means we know what the critical value is now. It is 7. So when you look up the probability on this side, the value there is not your critical value. It will be the next one along, the next one along. So this is 6. The critical value is 7. This is where our critical region starts from. So px greater than or equal to 7. So the probability of this region greater than or equal to 7. So 1 minus less than or equal to 6. And we can see that this probability is at most 10%. And just to show that 6 was not the critical value, if we do px greater than or equal to 6, the probability is more than 10%, it doesn't work. And it's good practice to show both of these to make it clear to the examiner why you've chosen 7 as your critical value and not 6. The actual significance level is the probability of the critical region, px greater than or equal to 7. We have that worked out here already, and as a percentage it's 8.98%. And I haven't given a test statistic here, so if our test value was 7, 8 or 9, we reject h0. If it's a value of 6 or below, we will accept h0.